In exercise 9H, you look at the chord of contact. Now, what that actually means is we're going to get the equation. Now, we'll actually be given the equation on your formula sheet for the chord. Now, you know a chord joins 2 points on your parabola. So you can see here that the chord of contact is actually this line going through here. It's created when tangents from an external point are drawn to the parabola. So there's one and there's the other one. And the points of contact from those tangents is joined. That's how you create this chord of contact. Now, in this situation, your external point is called x0, y0. I've actually seen in other textbooks that external point is called x1, y1. And so their equation looks slightly different. Like I just said, this equation is actually given on the reference sheet. So at most you could be asked to prove that this is the equation, or show that the equation for the chord of contact is a particular equation. They'll give it to you. There are many different proofs. The proof that I think makes most sense to me and seems to be the easiest to follow is not the one in your textbook. And so it's the one that I will use to show you the proof of how that equation comes about. Now, I'm just basically going to use some equations that you've already, and properties that you've already established. So, to start with, I'll write these down. Oh no, let me just answer this. What do you notice about this equation for the chord of contact? So here it is. You know, it's an equation of a straight line, so it'll have an x and a y in it. It's got the x ordinate and the y ordinate from the external point, and it's got an a or 2a. I guess for me, what I notice about that is it doesn't have any parameters in it. No parameter, no p or q. So I'm going to be working just very much in terms of the Cartesian equations. Okay, no, that's not exactly correct. I'm going to work with a combination of both. Okay, let me get started with writing down what I know in terms of what I've got here. I know that the parametric equation, so yeah, I'm just going to use both systems, the parametric system and the Cartesian system. The equation for a chord in general, the parametric equation for a chord is y is equal to a half p plus qx minus apq. Now, how different is where I need to get to from what I'm starting with there? Well, it's quite different in that what I said here, what do we notice? We don't have any parameters. So we need somehow to be able to remove these parameters. What's something else that we know? We know the point of intersection of two tangents. This is again in parametric form, is at the x value is times p plus q, and the y value is APQ. Okay, I think that's about it. They're really the only things I know, or I need to know. However, in this situation, the, what did they call it? External point is x naught y naught. Therefore, we know that x naught is the same as a times p plus q, and y naught is APQ in this example, in this situation. Now, I'm going to use that, keeping in mind that I've got this equation and I want it not to have any p's and q's in it. So if I could just focus on what p plus q was, then I would be able to get an expression for p plus q. And then it's pretty obvious, APQ, I've already done that. I could actually replace that APQ immediately with y naught. Okay, so let's do that. So y is equal to a half p plus qx minus y naught. That's looking a little bit better. But I think then I'll call that 1 and that 2. From 1, I can see that I could get, so the only other thing that I want to remove out of here is a p plus q bracket, and I can get an expression from p for p plus q from 1 in that p plus q in a bracket would equal x naught on a. So I'm going, and maybe I should call that one 3. I'm now going to sub 3 into this equation and get y is equal to a half x naught on a times x minus y naught. Now, I'm pretty happy because I've got the components of the equation. It's just not quite in the right form. I've got a term here with 2a in the denominator, so I'm going to multiply all my terms by 2a and get 2ay is x naught minus 2ay y naught, multiplying every term by 2a. I'm going to leave the x naught because I want that, and I'll have 2ay plus 2ay naught, just bring that term over, and there you can see that you get x naught is 2a outside of y plus y naught. Now, that is a proof. That's an acceptable proof. It's, like I said, it's not the proof that you have in your textbook, but it's an acceptable proof. I think the U2 is up there for 9H. Let's see how you go.